Hey everyone, Justin Waldron with J&L Woodworks here in Dameron, Maryland. Today we're not going to be making this bar that's in front of me. I did use the RTR-84 by Spark Robotics to make this, but what we are going to do is work on an organizer for your laptop, CNC bits, and also I'll have a free file located in the comments below.
All right, let's jump right in. You can see from when the file opens, we have 3 sheets. One's labeled wall mount, mobile cabinet, wall caddy. I'm going to work from the wall mount sheet today. The mobile cabinet is exactly the same as far as the storage and everything, except it's a taller cabinet, 35 inches tall, 34.5 inches tall, and you can put casters on the underside of this cabinet, and then it's mobile. The only thing that I didn't add to this sheet, and I was just double checking, is actually I did. On the bottom, there needs to be 2 pieces of plywood that are beyond the cabinet for stability. Then you can add your casters to that. For the wall caddy, I actually used this along with the wall cabinet. There's places here for 1/4 inch bits, 3/8, 1/2 inch, your collets, and then this circle just represents a 2.5 inch spoil board flattening bit that goes in the middle. What I've done with this one is added my mount for my wireless hand wheel and then recesses for my spanner wrenches. So if you wanted to add this to one of these sheets, you're just going to highlight it, right click, and then do copy to whichever sheet you want. You can move to the sheet. What I like to do is kind of keep a master sheet of parts that I may want to go back to later on for reference, or if I want to make any changes and duplicates, I still have that same original part that I can work from. So with that being said, let's go ahead and get started with this project. So the left-hand side of VCarve, hopefully everyone has watched some videos or played around in VCarve. This is all of your design options. I'm not going to use any of this today, but what I am going to start with though is your set job dimensions. This is the first part of getting into trouble with using your CNC machine. You'll generate tool paths and maybe you have your XY datum in the wrong position, whatever the case may be. So good habit to get in is just check your job setup, make sure everything is right there. So for this, we're going to use a 4x8 sheet of plywood, 48 inches, 96 inches tall. I've got my thickness set to 3/4 of an inch. Your plywood is going to vary. I have set the grooves here to 3/4 of an inch. And I did it that way just so no one would have to go in and modify for undersized plywood. You know, this is a storage cabinet. There's not a whole lot of structure. I hope no one's going to jump up and down on this thing on the wall. So we'll be just fine. And then when the screws drive into the plywood, most of the time it splits it and it'll actually fill that gap anyway. So moving on, our XY datum, we're going to use the lower left-hand corner. And what this means is this is where we're going to tell the machine we want the work to start from. So there's 2 things to look at. Our 0 position, we want that at the material surface. So when we get into Planetcnc and we get into the machine, we're going to tell the machine that we want our bit to be zeroed from the material surface, and we want our XY datum position to start at the lower left-hand corner. And this is the part where you get to the machine and you're wondering what the machine is doing because you think you had it set to the lower left, but you actually had it in the center or somewhere else. The last thing is your modeling resolution. If you see that it takes a long time to render your model at the end, it could be because your resolution is set really high. For this, you don't have to have your resolution set high. If you're doing a 2.5D carving or V carving, something with a bunch of intricate things in there, I would go higher just so you can see exactly what your tooling is going to do. And another place with the tool paths is your preview simulation quality. So I've got mine set to maximum. You can use standard for this. This is a new computer, so the processor is good, and I just leave mine there. So we're going to hit OK. We're all set there. We're going to start to generate our toolpaths. So early on, I had the habit of switching between both sides, but it is a good habit. In the upper left-hand corner, let's switch to our toolpath commands. And this is where we're going to start generating our toolpaths. Okay, so the first toolpath we're going to create, we're going to use an 1/8 inch end mill, and we're going to do our screw locations. And for this, we're going to use a drilling toolpath. And for today, we're going to stick with profile, pocket, and drilling toolpaths. So we're going to open this up. We have an 1/8 inch end mill that's already selected, 46-100. This is an Amana end mill. The feeds and speeds are already calculated, so it's all set and ready to go. If you're not using this bit, you need to check the manufacturer's recommendations for your feeds and all of that good stuff. And one thing I didn't do is I didn't include these two screw locations here. Shift is going to be your best friend in Vectric software. So we're going to highlight these screw hole locations. We're going to hold Shift, left click this, and left click this one. So now they're all highlighted. We've got our bit chosen. We're going to use PEC drilling. So we're going to retract above the height of the previous pass. So what this end mill is going to do is it's going to enter the work, make a cut, retract by 0.05, make another cut up all the way down. We don't want to dwell at the bottom of each pass. What we're trying to achieve with this, we don't want the bit to heat up. If possible, there's going to be a little bit of heat, but with drilling tool paths and some really small pocket tool paths, that's where we hear the CNC fires. Please don't leave your machine unattended. I should have said that earlier. We don't want the bit to get hot. It'll increase the life of the bit and, of course, reduce any kind of risk of fire there. So we're going to calculate this. We're going to cut all the way through. For me, I know that there's some people who don't like to cut into their spoil board. I used to be one of those people. I don't care anymore. A spoil board lasts me a really long time. I'm about a year on a spoil board, and I'm using the machine all the time. So for that, I'm going to cut all the way through. Here's our tool path. We're going to go back to our 2D view. And we're going to now generate another tool path. This is going to be for pockets. I'm sorry, for profiles. And these two parts here, I should have mentioned this earlier. This part is for your wireless hand wheel that'll go into one of these slots. And this is the most important part. This is for your coffee cup or your Yeti or Stanley or whatever anybody's using now. That'll go into this other slot. We could change to a different tool at this point, but since we're really not cutting out a lot with this 1/8 inch end mill, I think it's faster to leave the tool in there, make these cuts, and I designed it so there's a little bit of a tighter tolerance here anyway for these parts to fit together. So for this drill, we're going to leave this named as drill. We know what that is. We're going to come to profile toolpath. Our same bit is still showing. We're going to cut on the inside left, which means we want to cut on the inside left of these lines. We want to add tabs. So what a tab, actually, let me go back. Our tab length, I've got it set to 1/4 inch. They're going to be 1/8 of an inch thick. And we're going to add some tabs. So what a tab is the bit is going to come into the material, and once it gets to where it's 1/8 of an inch away from what we've said is going to be our overall cut thickness, it's going to get to this point, cut over a portion of material and keep going and leave 1/4 inch long, 1/8 of an inch tall. And that's going to keep this part in place with the rest of the material that's left on the table. Even with the vacuum table, some of these parts, can come up out of your work and get lodged at your bit, and it's not a good experience. So it's not a bad idea for any of these small parts to add tabs. The next thing we're going to do is we're going to add a ramp. So we don't want the bit to come straight into the material, then start cutting. We want to slowly ease the bit into the material, and we're going to have this ramp set at 1/8 of an inch. We will rename this to 1/8 inch end mill inside pocket or inside profile. It says we're going to cut all the way through. We're fine with that. There's our tool path. So what we're going to do at this point, this is the last of the 1/8 inch end mills we're going to use. We're going to merge these tool paths into one. So we're going to say 1/8 inch end mill merged. Then when you get to Planetcnc, you only have one tool path to open and run instead of two. So there's time savings there where you're not changing a bit, things like that. So we're going to go back over here to our toolpath screen. The next thing we're going to do is we're going to change our bit, and we're going to use a 1/4 inch end mill to make these pockets. So these pockets are for 1/4 inch end mills, bowl bits, and then your larger V cutting bits with the insert. So right now we're showing a different end mill. We need to remove this. We need to choose a 1/4 inch end mill. And this is going to be the 46315K. So this is the another Amana end mill. Our pass depth is 1/8 of an inch, so half the diameter of the tool. Feed rate, plunge rate, this was all taken again from the manufacturer's website. So we're going to hit select. And then for this depth, I want to cut 1/8 of an inch, so it leaves 1/8 of an inch of the tool exposed, so half of it. We're going to ramp our plunge moves again. And we're going to name this 1/4 inch end mill pocket. All right, and there's that tool path. This is for a 60-degree end mill, not end mill, V-bit, I'm sorry. So we're going to create this pocket at half the thickness of that bit. It's going to take 3 passes to cut that. Our plunge moves are still ramped, and we can name this 1/4 inch 60V pocket. And we're going to keep moving along. And for the sake of time, I'm just going to keep moving through this. These are 1/2 inch. So my cut depth here, I want at 0.25. I'm going to name these 1/2 inch pocket, 1/4 inch end mill. And then the last pocket we're going to make, these are 1/2 inch. We're going to do this in one pass. And I'm sorry, these are 1/4 inch. And I'll do 1/4 inch end mill. So at this point, we have all of these tool paths generated using a 1/4 inch end mill. If you don't have an 1/8 inch end mill, which is, a 3/8 inch end mill, which is what we're going to move to next, you'll have to go in and change what's coming up next to a 1/4 inch end mill. But while we're here, we're going to merge these, and you'll see this error came up. So that means one of these I don't have selected as the same tool as the other ones. So we'll have to go through here and see which one So something to keep in mind if you get that error when you're going to merge a toolpath. And I got that because I had this 1/8 inch selected there. So now we're good to go. So we're going to rename this 1/4 inch end mill merged. So now you can see what we've done is we have 6 toolpaths generated, but the machine is going to recognize 2. So there's going to be no pause in between these toolpaths, and that saves a ton of time. So whenever possible, if you can use the same bit for multiple functions, you're going to save a lot of time with that. So the next thing we're going to do, we're going to move to a 3/8 end mill, and we're going to create some pockets for spanner wrenches, calipers, anything else that wants to be stored in here. So we're going to move to a 3/8 end mill. This is going to be a 46011, and this is where you can see a big difference in speeds when you're moving up to 3 flutes. So we've got a feed rate now of 345 inches a minute, 100 inches for our plunge, and our pass depth is 1/2 diameter of the tool. You can push the machine can take it. You can do less passes. For me, I mean, you can do less passes. I did say that right. For me, I'm okay with this. I want to keep the bit cool. The machine can definitely cut it for sure, but I do like to have the cut quality there. So I'm going to be able to make this pocket in 2 passes. We're going to ramp our plunge moves again. And the rule of thumb here is 1/2 the diameter of the tool, or you can do more. So we're going to do 3/8 pocket. We're going to calculate. There are those pockets. These are going to be for the end mill and that important coffee cup. And I want to do half the depth of the tool. So we're going to go 3/8 end mill pocket. Calculate. These are for 1/2 inch end mills. All of this is still the same. So we're going to do 1/2 inch end mill pocket. There's those tools, or those paths rather. Right, the next pocket we're going to do, this is for the collet and that 2.5 inch spoil board bit. Plunge moves are all the same. We're going to do collet pocket. And we're almost there. So these are our dados and grooves. Same thing, we're going to do a pocket. I'm going to go 0.36. This is really all dependent upon your plywood, but this gets me close enough with undersized plywood. So another tip, done a lot of cabinet making. If you want to make a cabinet that's 20 inches wide and you need to figure out how wide that middle partition is going to be, I like to leave 3/8 of an inch of material on my cabinets after I cut dados and grooves. So 3/8 times 2 is 3/4 of an inch. If I want a 20 inch cabinet, I subtract 3/4 of an inch, and my center partitions need to be 19 1/4. So our plunge moves are still set the same. We're going to do dado, grooves, groove. We're going to do a 3/8 end mill, and we're going to calculate. Okay, so now we have our dados set up. The next thing we want to do is cut all of these parts out. So we're going to go to a profile toolpath, cut depth of 0.755. We're going to go back to that 3/8 inch end mill, 46011. And if everyone can't tell, these are the 3 end mills that I use the most of. So this can cut in 4 passes. We're not going to do a separate pass. We are going to add a couple tabs. If you don't have a vacuum table, I would recommend adding a tab on all of these parts. If you do have a vacuum table, I would only do these smaller parts. And you really only want to add tabs where you know you can sand, and avoiding like corners and circular ends and things like that. One tab should be fine on these larger pieces. Again, if you don't have a vacuum table. If you do have a vacuum table, this shouldn't be a problem unless your spoil board is erect. So it's completely up to you. We're going to do ramps again. We're going to lead in at 0.1875. And we're going to change this to 3/8 end mill outside cut. Calculate the toolpath. And then the last toolpath we need to create is this toolpath here. What I like to do when I'm cutting plywood is I like to go ahead and cut my parts away from the rest of the plywood that's left. So that's what this represents here. So I'm going to hold shift and highlight each one of these lines. We're going to cut on this line here. And so what's going to happen is the bit is going to come along and make these cuts and then enter down in again and go back and make the cuts. We don't need any tabs. We don't need a separate pass. We'll do ramps. And I'm just going to name this 3/8 end mill final pass. It's going to cut through the material, which is fine. So here's our project with all of our tool paths created. So what I'm going to do is merge these tool paths. So you can see with all of the tool paths that we've created in here, the machine is going to recognize these 3 tool paths when we open them up in Planetcnc. If we didn't do this way, the machine would make this cut, return back to XY, then you would have to open this tool path and keep doing this over and over again. So now we're going to preview all of our tool paths and see what it looks like. So I think it looks pretty good. All right, next we'll move on to Planetcnc. So now we're in Planetcnc and we're going to open up the first file that we created. So this Planetcnc, what I'm using right now, is separate from the one that's connected to my machine. So yours may look different when you open it up. So now our toolpath is open. And if we remember back, these were the first parts that we were going to cut out along with the screw locations. So in the upper right hand corner, we can see that this has our tool labeled as 46100. Their tool path is right here, 1/8 merged. Our material size is up here, so something to check there. All of our heights are showing 0, just because this is, again, not connected to my laptop. So at this point, our G code looks good. And the next thing that we're going to want to do is home our machine, which is this button here. And then from there, we're going to set our Z, Y, and X axes to 0.
Okay, so what we have is our bit is in our collet, and we chose the lower left-hand datum of our project in VCarve. So I have it circled here. That's where we want our bit to be, centered over the edge of our piece of plywood. Okay, and this is the Z height touch plate. So this is going to set our Z height automatically. And now we have Planetcnc, and I do have one of the files that are opened here. The lower right hand corner, you see a countdown. That's the spindle coming up to speed. In your upper left hand side, you see X, Y, Z. That's the buttons you'll push when you're happy with where your height is and your coordinates are. And then your spindle RPMs are also on the left hand side there. So this bit is spinning at 18,000 RPMs. The highlighted button at the very top of Planetcnc indicates that your spindle is on. Now that we've got our files loaded, we're going to go ahead and get started in cutting our material. This is a 1/4 inch end mill, and I've got this video running at 50% faster. Okay, and now with our parts cut, we're going to start assembly. I'm going to add some glue to the dados and grooves. The first panel to go in is this one that's shown here with the cutout portions for the USB cables and everything. And that's the most important one to remember. That one goes at the top of the organizer where the rounded over edge is located. The other two petitions just go in the other two grooves. And then there's the back that gets put on. So for the drawer assembly, it's pretty straightforward. Included in the file is the spacer block that'll be used to space your drawer slides. So the first drawer slide is mounted all the way at the bottom. The spacer goes in, and then your second drawer slide is put on top of that. And then here's the layout for the drawers. So there's grooves on all sides of the drawers. It's up to you on which bottom you put in which drawer, but I just simply nailed these together and then glued, and it's plenty strong enough. Also included in the file are the drawer fronts too.